Okay, folks, welcome to another session of PHI 215. This is actually a continuation of the other video that we did on functionalist theories of mind. So this one's just going to get into another section of that discussion. So let's get to it. So we've already looked at the basics of what a functionalist theory of mind says, Fodor's general defense of it, that it gets what's good about identity theory, but also what's good about logical behaviorism. And we also looked at Ned Block's Chinese brain objection to functionalism. So just recall the definition. It's the view that the mind is the functions that the brain performs. So people like Fodor are going to say that mental states are multiply realizable, so they don't necessarily require a carbon-based brain. Maybe if you could get a computer chip that performed all the functions that a mind does, that would be a real mind. You know, we've got an important analogy between software and hardware in computing, which we can also use for the mind. So the mind is kind of like software and the brain is kind of like the hardware. Another example, you know, you can listen to a song on cassette or on vinyl or on CD or streaming. You know, you can access this thing through many different versions of hardware. So in that way, we treat it as multiply realizable. Now, closely related to this functionalist view is this idea of strong AI. So AI just stands for artificial intelligence. So the idea here is that an appropriately programmed digital computer doesn't just simulate having a mind, it literally has a mind. So if you program a computer to perform all of the mind functions, you haven't made a simulation of a mind, you've made a duplication of a mind. So this view of strong AI is going to be closely related to functionalism, right? Remember, functionalism is just the view that to perform all of the mind functions is to be a mind, right? So if you can program a digital computer to do all the functions of a mind, then it literally has one. So Searle thinks that computers can't think. And he says the reason is that computers don't think or understand in the way that people can. So what happens is a computer just processes symbols by physical properties or some sort of digital ordering, whereas in the case of a human mind, it's processing symbols in virtue of their meaning. So the thought here is that so long as you're unable to recognize the meaning of something, you won't be thinking or understanding in the way that a human being does. So this is closely connected to an earlier view about artificial intelligence called the Turing Test, inspired by the great computer programmer and mathematician Alan Turing. So the Turing Test is supposed to be a way to assess whether a computer has genuine intelligence. So to pass a Turing test, the machine must perform in a way that an expert would not be able to distinguish its performance from a human performance. So for instance, we could imagine like a little chat conversation. You know, you could ask questions and you would have to figure out whether the individual on the other end is, you know, an artificial intelligence or a real one. And if you can't tell the difference, then that would mean that there's genuine intelligence in the computer, that it actually thinks. So remember, Searle denies that strong AI is possible. Remember, strong AI, when we contrast it with some other kind of view, which you might call like weak AI, weak artificial intelligence. Well, that's just computers behaving intelligently. So you might think that something like weak AI would be something like my Spotify algorithm being able to guess songs that I'm going to like, right? But in the case of strong AI, it's about literally having a mind. So here's what Searle says. Why is strong AI false? Well, he says, if the machine was responding to questions put to it in Chinese as well as a native Chinese speaker, so that other native Chinese speakers could not tell the difference between the machine and a native Chinese speaker, then we would have to say that the machine understood Chinese. So basically he's saying this is what we'd have to say if we accepted the Turing test. But Searle wants you to think that that can't be right. So have a look at this little cartoon in the corner of the screen. So this is what's happening with what Searle is calling the Chinese room. So basically, there's a Chinese symbol that gets put up onto this screen here, and then the operator inside is going to go into a rule ledger, a book of rules, and they're going to find whatever is put on the screen. And once they find what's on the screen, then they look up a reply, right, out of the rule ledger and put it into the output. Now, Searle is saying that basically, if you had the machine set up well enough, you could have a perfectly intelligible response to every input that's given. So the thought is, you could pass the Turing test using this system, but we wouldn't have any understanding. So the thought here is that if strong AI were true, then they would be able to acquire a cognitive capacity simply by implementing an appropriate computer program. But the Chinese room thought experiment shows that no such capacities of mind are achieved just by running a program. So even though we're performing the function of answering questions, that's not the same thing as acquiring a cognitive capacity. Therefore, no matter how nicely set up a bit of software might be, you're not going to actually get literal thought or literal mind out of it. So, strong AI is false. Here's one way that Searle puts it. You can see the difference between computation and real understanding if you imagine what it's like for me to answer questions in English as compared to this Chinese room thought experiment. One is actually recognizing what's being said here and giving an answer rather than just following the rule book. So Searle says there's a difference between manipulating syntax and using symbols semantically, right? So when we're talking about semantics, what we're really talking about is just talking about the meaning of words, right? So semantics is all about word meaning. The thought here is that there's no semantic understanding going on in the entire machine. It's just inputs, a rule book, and an individual who's not understanding the words, but simply following a rule. Give this reply for that input. And that's supposed to be an important difference, right? The thought here is that we have a performance of the function of a mind, answering questions, but that is fundamentally different from thought itself. So I guess the thought here is that just like in Ned Block's argument, right, it seems like there's something left out, right? So Block said that we still wouldn't have qualia even when we have the functions of a mind being performed by, say, a Chinese nation with two-way radios. And we've got another Chinese thought experiment, as it were. In this case, we have the Chinese room, where there's something missing in this performance of functions by a computer. So the thought is that semantic understanding is something more and beyond simple performance of a function. So another way to put this is that performance of a function is not sufficient, right? It's not a guarantee of a mind. So you could have something very much like a mind, functionally equivalent, without itself being a mind. So here are just some questions for further discussion, and we can take these up in the discussion boards on Moodle, and we can also get to them when we have our Zoom conversation. We might wonder, could it be the case that the mind is the functions that the brain performs, even if strong AI is false? So, do we have to believe that a very well-programmed, very functional system could do all the things and be completely indistinguishable from a human mind? Could we still have a reason to say that there's fundamentally a real difference between a mind, a genuine one, and artificial intelligence? We might also wonder whether there are any good alternatives to the Turing Test. Is the only way that we can identify a genuine mind in something, genuine intelligence, is to watch how it performs? Well, I can't answer those questions for you. Again, your job in philosophy is to work those questions out for yourself. But we've gotten a general look at what's going on with functionalism here. Fodor had the idea that functionalism kind of captures this nice thought that, the mind isn't some extra thing that exists in the universe. It's just a way of how the brain acts. And moreover, it's a way that the brain acts that can explain how mental states cause physical states. So it's supposed to be a nice parsimonious theory. But as we saw in the arguments from Searle and Bloch, it seems that we would have to say that minds are in places where common sense doesn't tell us that minds are. So we might have to try to find a way to refine the functionalist theory so it's not liable to these objections. Or maybe we have to realize that there's something right about these objections and that maybe the functionalist theory should be abandoned. So I'll leave that to you to think about. And thanks for listening in today. All right, take care. Bye.